I want you to now start looking at our main task here is going into the North Pacific gyre slash that date, and when you type in ls, you must see these files. So let's get to the point where we're all able to see this. So navigate to this directory and type in ls and make sure you're looking at all these files. Is everyone here? Okay. So we have a bunch of files here that all look like this. They're all very long files, so I just want to have a peek at one of these files. How am I going to do that? Remember that these files are fairly long. You can run wcl star.txt, and you see that most of them are 300 lines long, which means that if I cat it, it will far exceed the length of my screen. I just want to have a look at the first few lines of the file. Head, and then let's just say one of these file names. They all look like this, and everyone remembers what this means. Can someone tell me? The first line there, what's the 288? It's the ID of a protein. Every sample has about 300 proteins, and each protein has a line of its own. So, for example, 288 corresponds to protein number 288, and the second number here corresponds to the relative amount of that protein. And so, obviously, the protein number 275 here is not nearly as abundant as protein number 288. So, all the files they have this simple structure, and we have this program called Goostats, that someone wrote for us. Goostats will operate on each of these, on a file, and produce some kind of output. And the way you use Goostats, I'll tell you right now, it's a bash script. Is you say bash Goostats, and then you provide it, let's see here, with some file that you want to analyze. And then you provide it with the file that you want the output to go into. Right, so this will run the analysis on our first file, ne017298.txt, and it will put the output in this new file, output.txt. And when you run that, it will take a few seconds. But when it's done, you should see this new file, output.txt, being created. And you can have a look at it. It's nothing special. It just has the least abundant and the most abundant protein of that file. So here's what we want to do. We want to run the analysis on each one of our files. Okay, so we want to run this Goostats script on each one of our files. And we have, right now, we've got maybe 17 or so files, but we can potentially have several of them. How are we going to run the analysis? So how are you going to run this Goostats script on all of our files? Okay, so someone says bash Goostats star.txt. Before I run this, please don't run this yet. You can put this command called echo in front of any other command, and it will just print the command itself. But if there are any patterns like star in that command, it will expand them. And so here's what you're trying to run when you say bash goostats.txt, star.txt. Can someone tell me what's wrong with this? Why this is so dangerous?
It'll include the output.txt file as well.
It will include the output.txt file as well. Okay, I'll get rid of it. I don't care. And then let's have a look at what's going to happen again. Why is this so dangerous?
You would overwrite the second one.
You say it overwrites the second one. Does everyone agree that that's a bad thing? Right? Remember the way we used bash goostats before. We said bash goostats, analyze this file, and put the results in output.txt. And so now if we run this command here on dot, bash goostats file 1, file 2, it will analyze file 1 and will put the results in file 2, which means the data that we have in file 2 will be lost forever. And it turns out that the rest of the files will just be ignored. Nothing will happen to those files. They won't be analyzed in any way. Their output won't be anywhere. Okay, so what do we do? Let's just say we had 2 files. Okay, not several thousand, but just 2 files. How would we analyze them? Sorry, what? Create a loop for 2 files? Really? Is it worth the effort? So you know, it would be easy. We would just say output 1.txt. Do that for the first file. And let's just say we do the same thing for the second file, but now we'll put the output in this second file, output 2.txt. And we're done, right? That's how we can analyze 2 files. And 3 files is slightly harder, but not impossible. 10 files is starting to get a little bit of a pain. And 100 files is almost impossible. And 1,000 files is undoable. So we want to be able to run this command over and over and over again. Except every time we run that command, these 2 names are going to change. And a lot of you have done this with programming before, right? You've written a loop in some kind of programming language before. How many of you have written a loop in some programming language? Okay, it's also important to know how many of you have never written a loop before? Never written a loop before? Okay, all right.
Sorry, can I ask a question about bash?
Yes, please.
So it gives the mean and the max, but does it give the mean and the max for the protein number or the amount of that protein?
I've got no idea, I made it up. Let's see. 17298.txt.
Research the second number.
It gives you, sorry, let's have a look at output 1.txt. It gives you the protein that I guess is the least abundant, so has the minimum amount, and the protein that's most abundant. So in this file, ne017298.txt, it gives you the protein that is the least in that sample, which is protein number 138, and the protein that is the most in the sample, which is protein number 229. I'll just give you a little bit more background about this script. You see that the script pretends like it's doing a lot. It takes a while to run, but you see that that's only because I make it sleep for 4 seconds. All right, so it's really not doing much. It's just a pretend script, but the idea here is not what the script is doing, but the fact that we need to apply it over and over again. And to do that, we need to learn how a loop works. So let's do that. Let's start with a very simple script, a very simple loop. That will do, let's say, something like this. For file in star.txt. Okay? We're writing a for loop here. And don't worry if this line doesn't make a whole lot of sense. When we hit the enter key here, you see that no output is produced. Instead, our prompt has changed. We no longer have a $ as a prompt. We have this thing. And that generally implies that the shell is waiting for more input for the same command. Actually, it's waiting for a loop. So a loop begins with the word do. And inside the do, you have to write whatever needs to be looped or whatever needs to be repeated over and over again. And here we're just going to do a very simple thing. We're going to echo or print file. Okay. And once the loop is done, once you've entered the commands that you want to execute over and over again, you can type done. Okay, and what that does is this, it just prints all the txt files. and I know that for some of you this might not make a whole lot of sense yet, but let's write a few more loops and then you'll be more familiar with the concept. So here's what we did. For file in star.txt, do echo file done. And remember, this $sign is really important. Let's rewrite the loop without the $sign and see what happens. So for file in star.txt, do echo file done. Remember, I did the same thing here, but I didn't include the $sign with the file. What do you think this will do? Actually, there's no way of predicting, but what it does is it echoes file several times. Let's write one more loop and maybe the concept will be clear. Let's say for file name in star.txt, do echo file name with a $sign. Done. So here's how the loop works. The first line says to the loop what you want to loop over.